Hello everyone, welcome back to my channel. I hope you are doing extremely well. So today we will be continuing our previous video, that was fraud jump with K distance. So yesterday we have solved using two technique to approach, that was one is recursion and one is dynamic programming. So in dynamic programming we have used uh, memorization method, which was nothing but top down approach. Now we are going to learn how can we solve that question by using tabulation method. So let's see one example. Let's see, there is an array, and let's there is some value, okay, 5 2 like 4 7 6, and let's say 9, let's say 3, right? So what, how we have solved that one? Just we don't have to, like, it's not that much complex. Just we have to understand little bit, and we can definitely convert that recursive, or you can say memorization technique, a DP, into a tabulation DP, right? So let's see, there is 1D. I will create 1D DP, okay, and this is the, there would be only one element, single element. Then in that case, what I will do, in that case, if there is only one element, then the required energy would be 0, right? And 0. So let's assume, now I will decrement the pointer here. So let's assume, let's see here, if there are two elements only, so what would be the minimum energy? What would be the minimum energy that needs? So definitely 6 minus 3. So I will put here 6 minus 3 is 3, right? And C, let's decrement the point to here. Now is 3. So what would be the minimum? How, if and given value stays given the 2? So the what would be the path to reach to the end? Either I can take to here, then here, or I can simply take to here, right? So here we know that from here we can reach the uh, last step at the minimum energy is 3. So see, from here to here, from 3 to that's 4, what would be the minimum energy? Is 1, okay, plus this value is 3, is 4, right? But if I will take at most 2 step, so what would be the energy? That is 7 minus 3 plus at the last, in last step, my energy is 0. So that is 4. So both are, what would be the minimum out of both is 4. So I will assign 4. And if you can see here that at minimum there is a 4, either C, either I can go by 7 minus 6 is 1 plus 3, 4, or I can directly take 3 to 5, that is 4. So minimum energy is 4, right? See here, let's assume that we are at here at index 2. So what would be the minimum energy that I need to reach from step 2 to a last step? Either there would be a two-way. Let's erase that and see. From here, either I can take 1 step or I can take 2 steps from here. So if we know that to reach from 2 step to 3 step, I need energy 4, and here from here to reach to the end, we know that minimum energy would be 4, right? So see here, so let's step 1 means if take step 1, then the energy would be 4 minus 7 absolute plus attendance 3 is 4. Or if it takes step 2, the energy would be what would be the energy? That is definitely 4 minus 6 plus attendance 4, the minimum is 3. So what is the value? 4 minus 7 is 3 plus 3 plus 7, sorry, yeah, 3, definitely 7. From here what would be the value? 5. So out of 2, what is the minimum? Minimum is 5. If we are at this step, so again we will do same thing. We will do same thing from here as well. That step 1 would be what? From index 1, I can take one step, that would be 4 minus 2 plus at index from 2, what would be the minimum? That is 5. And if I will take 2 step at a time from 1 index, so what would be the value? That would be definitely 7 minus 2 plus at index 3, the value is 4, right? So that is 9, and here 7. So from here I need minimum 7 energy. Same we will do for the very first index, right? And see here, from 1, if I will take one step, then from 1 to 0 to 1 I need 3 energy, and at index from 1 I need 7, so it's 10. And from if I will take 2 steps at a time, so that would be 1 plus 5, that is 6. So what is the minimum? That is 6. And from where I get this here, see what can I do? From 5 to 4 I will go by 1 energy, or from 2 to 6 I will go by 2 energy, and from 6 to 3 I will go by 3 energy. I will add all, so the total energy is 6. So this is the basically a tabular approach where I have solved this using iteratively. Okay, I haven't used any recursion here. So let's try to write down a pseudo code for this. Let's say, and this pseudo code is a language independent, so you can write whatever language you are comfortable in. So let's int function, and we got definitely be one array, it's called nums, int n is let's try to write down on dp. At the very first I will initialize the last index value with 0, because let's assume that if we are at if there is only one element, then definitely be 0. It means that, so what is that mean? That we can also say that from here what the minimum energy we need to reach the end, as this is the end, so we need 0 energy to reach the end, because this is the end. So that what means to initialize it with a 0. Okay, so now what we will do, we will just simply write down one for loop. Okay, just that I will goes from n minus 2 till the 0th index, and what can I do here? Just simply I will do I will take one minimum value, minimum, okay, minimum energy that will be initialized with the maximum value, max value, and I will take one loop that will execute till the kth step. So step to 1 and step till k, step plus plus. So let's see here, and again I will check first the base. I'll check the base case that if exceed the like array, means simply if I plus step equal to n, then in this case simply break. Okay, otherwise I will definitely minimize the energy equal to min out of either minimum energy or like to, and will do, I will just simply try to find out the absolute value, absolute difference between nums I minus nums step plus I. Step plus I, right? Yeah, like minimum energy, minimum energy absolute nums I minus nums step nums absolute nums I minus nums step I, and yeah, that's it. After that, what is happening after this thing? Case step, I will slice at the dpi with minimum energy. That's it. And at the end, what I will do? Simply, I will return the dp of 0, because we know that from the 0th step we automatically know what would be the minimum required energy to reach to the nth step. So this is all about the tabulation here. If I talk about its time complexity, so definitely it is order of n, because we are executing one loop from I equal to 0 to n. And if I talk about the space complexity, as we are using one taking one dp of n size, so definitely space complexity is order of n. So that comes to our code editor and try to code it down. But the very first I will simply initialize the length of the height. So n is not length. Yeah, and I will also check the base case if no element is there. If one or no element is there, then simply return the 0. I will initialize one dp, like initialize create one dp array for tabulation. Int dp is a new int n, and at the very first from n minus 1 index from last index, uh, the minimum energy to reach last basically stair is 0, right? So I will initialize it dp n minus 1 0. Now integer I will start from n minus 2 step, because we know that, let's see, because we know here that see because we know here clearly that from if we are at from here, we no need to we the minimum energy is 0 from here. Now we have to calculate then what would be the minimum energy to reach the last stair. So definitely for here I will, that's why I started from n minus 2 and I goes till 0th index I minus minus, and let's take one minimum energy that I will slice in with max value uh, let track minimum required energy. Okay, now I will go step from 1 till kth step. Now what is the value would be there, a minimum energy that would be, before that I check either if we reach the last step stair, if we are exceeding the last stair, if basically step plus I is greater than n or greater than or equal to n, so in that case simply break or check the minimum and update it. Minimum energy will be math dot min or minimum energy, then or math absolute norms height I minus height step plus I. At the end, what will we do? dpi, I will just initialize that. It means that it indicates that from the ith index the minimum energy would be this value, right? And at the very first, just I will return the 0. Okay, and here just to let update in initialize the minimum the minimum energy to reach last step. I hope it would work perfectly fine. Let me check. Okay, so it's giving me the error. Let me check what is the error now. Yeah, yeah, actually it's my bad. Actually I have to add here while calculating. This is the current value, say, right? Or for the separation, or you can also say that into current energy would be this one. So I hope it works perfectly fine. Means this is the current energy and this is the minimum energy that we have already calculated. Now let's try to submit the code, and yeah, it worked perfectly fine. So yeah, this is all about for today's video. So this is that. So we have learned how can we do through recursion approach, how can we do through DP using memorization and tabulation. I hope this video helps you a lot to understand the concept, and thank you so much for watching the video, and I will come back with another important video for you. Till then, bye bye, take care.